This is an example of a computer model. Computer models have been in the news lately because of the climate models, for example. And I thought it would be useful to describe what a computer model is. A computer model can replicate a real world system. In this example, I'm replicating the lunar orbit around the Earth. And the science is well understood for orbital mechanics. The equations came from Isaac Newton, and the two in particular that are being used in this model are illustrated here in the blue text. The green text represents the initial conditions, and every model has to set up what the initial conditions are. In this case, for example, I'm showing the mass of the Earth, the distance to the moon in meters, and initial velocities, initial positions, that sort of thing. The angle of the moon with respect to the Earth. In the toolbar, there's a button here called single, which I'm going to click. And that just means that it will stop after a single rotation around the Earth. And in that case, it'll tell us exactly how long it takes for the moon to orbit the Earth. And this would be one of the reasons for creating a computer model, is because they can run much faster than a real system. And that gives you the opportunity then to look into the future and see the position of a planet, for example, which the technology I'm demonstrating here is, of course, used for that. If we send uh, a satellite into orbit around the moon, then the calculations necessary to make that happen are the same types of calculations that I'm making for this model. And one of the points of this demonstration is that if the science is well understood, then any number of engineers can create this model and they will get exactly the same results if they know what they're doing. But what models don't do is they don't create science. They can only demonstrate if you understand the science or not by making a prediction and seeing that prediction come true. In this case, we're going to predict what the uh, orbit of the Earth is, orbit of the moon is around the Earth, and predict how many days it will take to go around one complete orbit. So when I click on the Run button, um, the model will start running. And I'm going to pause it here just to illustrate some of the internals. The acceleration of gravity from the Earth to the moon is along the hypotenuse of this triangle. But in order to calculate x and y positions and to calculate x and y velocities, um, we have to convert that acceleration into vectors representing a y vector here and an x vector here. Just knowing the acceleration along the hypotenuse is not adequate. And some of the calculations that you see over on the right side in the green text uh, represent the distance to the moon in meters for the x direction and the y direction, the velocity in the x and y direction, and the acceleration of gravity in the x and y direction. So that's just a little insight into what goes on internally. I'll let it continue to run and finish one cycle, and we can see what it predicts as the orbital period of the moon. And in this case, it says it's 27.3. If we do a query on the web, you can see any number of pages that will tell you that the orbital period of the moon is 27.32 days. So the model is able to accurately predict that. And that's really all I wanted to convey. That if the science is understood, then any number of people can duplicate the same results. But if the science is not understood, then every model is probably going to give you something different because everybody's using a different interpretation of the science.